Algebra 2 students, Mrs. Myers here. Today we are going to be taking a look at lessons 4 through 7, day 1. Okay, so we're doing a little rearranging here with this module. But anyway, this is still talking about values of trig functions. Okay, we're going to be talking about all 6 trig functions values here, but we're going to do it in a slightly different way. We're going to be toggling back and forth between one trig function's value and another trig function's value. All right, and then there's a second day of this that is going to come next week on Tuesday. But for right now, let's take a look at day 1 of this. So quick little reminder here, we're going to be using our 9-letter acronym of SOHCAHTOA in these problems. So we want to remember that the sine of an angle is equal to opposite over hypotenuse. We want to remember that the cosine of an angle is equal to adjacent over hypotenuse, and that the tangent of an angle is equal to opposite over adjacent when we are dealing with a right triangle. Okay, so in your right triangle, okay, when you have some angle labeled as theta, right, here would be your opposite side, here would be your adjacent side, and here would be your hypotenuse. Now, the other thing that we want to remember is which trig function reciprocates into which trig function. So we've got ourselves cosecant theta, which is the reciprocal of sine theta. So that would mean that cosecant theta is hypotenuse over opposite when it comes to a ratio of sides in a right triangle. Okay, next we get to the secant of theta, and that's the reciprocal of cosine theta, so it's 1 over cosine theta. And that means that if cosine theta is adjacent over hypotenuse, then secant is hypotenuse over adjacent, right? That's the ratio of sides for a right triangle for secant theta. And last trig function, that's the reciprocal, and that's cotangent, which is 1 over tan theta. So if we know that tan theta is opposite over adjacent, then that means that cotan theta is adjacent over opposite. All right, so we just got a couple of quick problems to tie this all together here. And we're going to start with me telling you that the cosine of theta is equal to a value of 7 over 15. Okay, and I want you to find the sine of theta. But moreover, I'm going to tell you that theta is in quadrant 4. Okay, so when if you were to think about sketching your angle, okay, in standard position, okay, you would have the angle land here in quadrant 4. Now, remembering these 4 letters, okay, that tells you that cosine would be a positive value, but the other trig function, sine and cosine, would have sine and tangent would have to be negative. So that's going to be important here with this problem, okay? So if I tell you that the cosine of theta is 7/15, it just means that I can draw a triangle in this quadrant, okay, with the angle being in standard position, and I can have the ratio of the adjacent side to the hypotenuse being 7 over 15. So I can actually draw that if you want me to. Okay, so just gonna put my right triangle there with my angle in standard position. Remember, so standard position is rotating around this way. Sorry, that would be theta. But then the reference angle would always have the same trig function value as the original angle, and I want to make sure I put that in reference angle position, so terminal side to the closer part of the x-axis, okay? So the adjacent side would be a 7, so that would be right there, and the hypotenuse would be a 15. Now what I want is I want the sine of theta. So the sine of theta's ratio is opposite over hypotenuse. So you see I don't know this opposite side here. I do know the hypotenuse is 15, but I don't know this opposite side. So how am I going to find it? So I've got 2 sides of this right triangle, and I need to know the third side. So how I do that is I use the Pythagorean theorem. Okay? Now I always like to use leg squared plus leg squared equals hypotenuse squared for Pythagorean theorem. So we go 7 squared, okay, plus, now I don't know this, okay, so I could just call that some variable, let me call that a squared, and then 15 squared. So now I square this number 49, okay, square this number 225, minus the 49. That would give me, let's subtract here, 6. Okay, so it's a squared, all right, is equal to 176. And then how am I going to get my a value from that? All right, I'm going to take the square root to get from a to from a squared to a, and I'm going to try to square the root of that, but that does not give me a nice rational value. You can't take the square root of 176, and I'm just going to leave it. Okay, now if that was a nice perfect square and that was a nice rational number, by all means you'd give it, okay, but it's not. So that is your opposite side length, and you put that back up here. Now, from that point on, okay, you want to make sure you remember that you're in quadrant 4, which means that your sine value would be negative, right? See, because that would actually be a negative length to come all the way down here to this coordinate, right? That y coordinate would have to be a negative, and that x would be a positive, all right? And then the y is, if we're talking about being on the unit circle, okay, the y would be your sine value, so that would be as to y, that would be a negative, okay? So let's do one more problem like this. Okay, so I'm going to give you if the secant of theta is a value of -6/5, and I want you to find tan of theta. And what I do is I tell you an interval of angle measures that your theta measure is going to be between, okay? And so this right here is actually telling you a quadrant. So let's just do a quick little sketch here and see what quadrant we're in, okay? So 180 degrees would be right here, 270 degrees would be right here. So this is basically just a fancy way of saying that we're in quadrant 3, okay? So if we are to sketch our terminal side from standard position being quadrant 3, okay, so this would be theta, but I want to be able to draw that right triangle so I can use that SOHCAHTOA idea with the secant value and get the tangent idea. And I want to make sure I put that right triangle such that the reference angle right here would be, okay, in the triangle. So that would be the way that I would draw the triangle in quadrant 2. Always use, okay, reference angle position. So secant being the reciprocal of cosine, and cosine being adjacent over hypotenuse, means that this must be hypotenuse over adjacent, okay? So hypotenuse is the 6, okay? Adjacent is the 5, okay? Now, that's just a negative value because I'm down here in quadrant 3, and every time I know I'm in quadrant 3, I know that the tangent values can be positive, but I know that my sine and cosine values, hence my secant and cosecant values, would also be negatives, okay? So that's why that's a negative. But, you just got your hypotenuse is 6, your adjacent is 5. So I need tangent, okay, which is opposite over adjacent, and I don't know that opposite. So once again, I use Pythagorean theorem, okay? So leg squared plus leg squared equals hypotenuse squared. My hypotenuse is a 6, so I fill that in. Now I don't know one of the two legs, but I know the other, so I could just go a squared plus 5 squared. Okay, so a squared plus 25 equals 36, minus 25, and a squared is equal to 11, square root, and you get just a equals square root of 11. Again, if that's a nice perfect square, you'd write it as a rational value, but it's not, so you just leave it. So I'm going to come over here, and what is tan theta? Okay, so that was that opposite side that I was trying to solve for, it, square root of 11, over, okay, now I've got my adjacent, which is 5, and that's going to be a positive value because I'm in quadrant 3, and that's good. All right, just a word of caution is if this radical had been in the denominator, I'd rationalize my denominator, but it was in the numerator, so I was good to go. And that is it. Okay, so we kind of follow up with this idea for another lesson next week, but for right now, this is all that we've got for this one. So you got a few problems to try, and I hope that goes well for you when you work on them later on. All right, be well, everyone. Bye.